Okay, I'm recording now. So we did. Okay. Are we done?
Yeah.
Good. Okay, so we have been looking at trigonometric equations and solving them. Today what we're going to be doing is looking at trigonometric functions. This is mostly a revision that we did last year, the graphs of them specifically. And there's a little bit of content that we didn't see last year that we'll be seeing that we're adding on today. So the graphs of trig functions So what graphs do we have that are the main ones we're interested in? Cosine. So we have the sine graph. Which the sine graph we all know looks like this. And our cos graph looks like this. Okay, thanks for that feedback on my drawing. Okay, so we've got our cos graph and our sine graph. Now these are functions. So we have our functions f of x equals some periodic function. So I'll mainly be working with sine because it's a good example. So we have our sine function. Okay, well, f of x equals sine x. Now, just like any other type of function, we can add some parameters to this and change what the function looks like. So what's the first one that's really easy that we look at that shifts it up and down? Okay, well, we used what did we use last year? I think we used a C. We're going to use, let's start with the amplitude. So the amplitude is the A. So if we had a variable in A sine x, the A gives us the amplitude. Okay, now the amplitude is going to be the same no matter what the sign on the A value is. So really, amplitude, because remember, amplitude is like a distance. It's how far above or below that the graph gets to. So it's like the max or the min of the graph. It doesn't care whether it's positive or negative first. In fact, we're going to find that we can make it positive or negative, doesn't matter what it is, using a horizontal shift. Okay? So the amplitude is just the distance. So we always use it as positive, so that we have absolute value. So we all hopefully recall that these two lines are absolute value. It just makes whatever's in them. It might have been, we'll go with a big A today. It doesn't really matter as long as we know that that A means the amplitude. I'm not going to restart the whole recording. Okay. So we've got our amplitude. What else? How else can we change the function? B, there's a simple one to do. If we add something onto the end of it, what is that going to do? A plus C. Yeah, I'm going to use a plus D. I'm going to double check this. Yeah, we're going to use a plus D. So we also have, because we're going to use C for something else. Okay? So if we want to change the median position, we're going to add something onto our periodic function. Now, what I'll do after we finish the recording is I'll jump on Desmos and I'm going to create sliders for each of these variables, and you'll be able to see how they affect the graph. But for now, we'll just do it on paper because it turns out that I can't record the screen capture thing. So I can shift. This is the vertical shift. So when I draw a graph like this, I'm simply going to put a dotted line there where the x-axis would be, and that's actually the d value. So that's my graph there. Okay, so if d is negative 2, it means I've shifted my entire graph down by 2. If d is positive 3, I've shifted it up by 3, so this would be 3. So wherever the median position is, we always want to show it on our graph. So that's the median position. The median position is the vertical shift. Okay, so there's two of the attributes we did last year. We had one more. Does anyone remember what we did last? Horizontal shift? We didn't do that one last year though. Which one did we do last year? The period? Yep. So if we have, no, we didn't do horizontal shift last year. Did we? We might have touched on it. It wasn't assessed anyway.
No, it wasn't assessed.
Wasn't assessed, but we touched on it. Okay. So we did have, if we added in a value bx, if we added in a value bx, the b, what does that tell us? So the period is b. We sure about that? No. So there we had a little formula, 2 pi on b. Okay, so the period is 2 pi on b. Now we had also the period, we used the symbol big T. I don't think the textbook uses it, but I use it instead of having to write period each time. So I'll shift this up. Okay, which means, because we have this nice little equation here, let's say we have the period, but we want to know what b is. We can rearrange it and go, well, b is 2 pi on the period. Okay, so we can swap the b and the t depending on which one we have and which one we want to find. Is that pretty clear? That's all work we did last year. Okay, I'm going to just move on from that for a moment. Now let's say we had, let's say we added some value in there. I'm going to leave the b there. So we have sine of bx plus c. Okay, we've got sine of bx plus c. Now, remember when we had some sort of function, so let's just put that aside for a moment. If we had some sort of function and we were giving it a horizontal shift, so let's say a quadratic. Remember when we did quadratics? Quadratic, and we had f of x is equal to a x minus h squared plus k. You guys recall that? That does look familiar some way, doesn't it? And this is turning point formula, so the turning point was hk. So this is our vertical shift, and this, the h value, is our horizontal shift. So really, if we had something ax squared, and we wanted to shift it horizontally, we take the a variable and we replace just that a variable with something else. That's a hk. So, yeah, so we have ax squared. This is the horizontal shift. Okay, we're replacing just the x value. Okay, so let's look back at the periodic function here. Now I've taken this sine of bx and I've added something on. So to give me the value of the horizontal shift, I really need to factorize what's in here. Okay, so I'm just going to go through what I'm doing, and then I'm going to give you the actual thing that's important, so like I normally do. So I just want to explain, because otherwise you might be a bit confused. Well, you might be a bit confused anyway, but I'll try my best to mitigate that. Okay, so I'm going to rearrange this to have the x with something else in brackets. Okay, so I have sine. Now, if I factorize this, I'm going to take out the b, because I want the x by itself. And then I also have to take b out of the c. So really I have c divided by b. Okay, so the horizontal shift is c over b. And this, because this is positive, unlike over here, now if this were me doing this, I would put a minus there, but the textbook doesn't do that, so I'm going to follow what the textbook does. But now the h value shifts it to the right, whereas because we're plussing it, this is going to shift us to the left. Okay, so the thing you need to remember, and the reason that that's okay, is because whereas in the quadratic, in the turning point formula, that's giving us an x value, right? Whereas here, that's giving us a phase shift, which is kind of like it's not a turning point, it's not any important point, it's really every point that's shifting back. Okay, so we just have to remember that. Now, why do you think that I'm giving you in this form and not this form? What's wrong with this form? It has double brackets there, and they're going to get messy and annoying. So I'm going to keep this one. So we have f of x equals sine of bx plus c. We have that. Then our horizontal shift is b over c units. It sure is.